we're going to look at how to write numbers using scientific notation while keeping sig figs in mind. So the idea of scientific notation is that it's a convenient way to write really large numbers or really small numbers. And so sometimes it's not convenient to write things in scientific notation, and sometimes it's really convenient to write things in scientific notation. What you'll see is that some of my numbers are not that convenient to write in scientific notation, but I'm using them as examples because the numbers are generally easy to write. So, a number written in scientific notation will also reflect the correct number of sig figs. So here is sort of a general formula for what it looks like. This looks more confusing than it really is, but just so you know, this value right here is your value in the correct number of sig figs, and it should start in the ones place. So it should be a number that is in the ones place, so something like 1.487 or 9.682. Generally, we don't write in scientific notation in the tens place, so we don't write 90.89 or 68.74. So this number generally starts in the ones place. And then we write our value times 10 to the, and the exponent reflects how many times we had to move our decimal in order to get to our value c. So a positive exponent represents a very large number, and I'm going to show you that in a second. So an exponent greater than 1 means that, we must have a number that is times 100 or 1,000 or 1,000,000. So it's a really big number. A negative exponent, or a number smaller than 1, means that we're looking at a really small number. So that means like times 10 to the negative 1 is basically, times a tenth. Or times 10 to the negative 6th is times a millionth. So they're very small numbers. So let's look at example here. So I've got numbers written in standard form and then written in scientific notation. So a couple of things to keep in mind. This first number has 4 sig figs, so the 1, 4, 9, and 2. So that means when I write it in scientific notation, it also has to have 4 sig figs. And generally what happens in scientific notation is that my number starts in the ones place. So over here when I write it, I'm going to write it as 1.492. And in order for this number on the right to be equal to this number on the left, this number is 1,492, then it's got to be 1.492 times 1,000 basically, because 1.492 times 1,000 is 1,492. But in scientific notation, we don't write times 1,000. Instead, we write times 10 to the third, because times 10 to the third is 10 times 10 times 10, which is the same as saying times 1,000. So 1.492 times 10 to the third power, and then you always write your units at the end of your number. Now generally, what I do is I just see how many times I would have moved my decimal. So if I look at standard notation, my decimal would have been here after the 2. I move it 1, 2, 3 times. That tells me that my number is going to be times 10 to the 3. So if you move your decimal 3 times, then your exponent is going to be 3. So let's do it again. I've got another number, again, only 4 sig figs because these are trailing zeros, and there is no decimal, so these trailing zeros are not significant. So I'm only going to have 4 significant figures when I write it in scientific notation, so it's going to be that 1.492 again. But this time, when I moved my imaginary decimal, had there been a decimal, it would have moved 1, 2, 3, 4, 5 times. So it's going to be 10 to the 5th. Because this number is actually 149,200. So it really needs to be 1.492 times 100,000. And was that? Yeah. So 100,000 is the same as 10 to the 5th. All right, so let's keep going. Let's keep trying this out. Our next digit here has 7 sig figs. It has 7 sig figs because there is a decimal present. That makes all of these trailing zeros significant. And so when you write this in scientific notation, you have to have all 7 significant figures. That means, again, I would still write it as 1.492, but you have to include the rest of those trailing zeros because I already said they were significant by writing that decimal. So in this case, I've got all 7 sig figs here, and then times, and if I were going to move that decimal, it moves 1, 2, 3, 4 times to the left. That means it's going to be an exponent to the 4th. Which makes sense because, again, this number is 14,920.00. So I would have to multiply this number by 10,000 to get it to be 14,920. And again, 10,000 is the same as 10 to the 4th. All right. So we've looked at really, really big numbers. Let's start to look at small numbers. So when I'm looking at small numbers, those are numbers smaller than the ones place. I'm looking here, I've got a leading zero. Remember, leading zeros are never significant. And I've got 0.9002. I've got 2 captive zeros. Those are always significant. So I have 4 sig figs here. That means I have to have 4 sig figs in my scientific notation number. So I'm going to move my decimal again so that my number starts in the ones place. And then times 10 to the whatever power I need to use in order to represent that original number. So in this case, I move my decimal 1 time to the right. Now it's because my number is very small that I need to do this. So my number is actually 9.002 times, and 10 to the negative 1 is the same as 1/10. It's the same as 0.1. So if you put 9.002 times 0.1 into your calculator, that's going to come out to be 0.9002. So again, not the best way to write this particular number, but our numbers are going to get very, very, very small, like times 10 to the negative 23. And so instead of writing those very, very small numbers, it's going to be more convenient to write it in scientific notation. All right, so let's do another small number. So again, none of these leading zeros are significant. The 9020 are significant. That last zero is significant because a decimal is present. So I've got 4 sig figs here. That means that you're going to have 4 sig figs in scientific notation. So that 9020 are all going to be significant. We always start our number in the ones place. And times 10 to the what number? So 1 over what number gets me to this really small value? Well, that 9 is in the thousandths place, so it's going to be, right, 1 over 1,000. So if you do 9.020 times 1,000ths, then you're going to come up with 0.009020. All right, so we're going to do one last one, and this one is going to be super important because sometimes scientific notation is the only way you can write a number with the appropriate number of sig figs. So 9.00 times 10 to the 4th grams is very, very similar to saying 9 times 10,000. So basically 90,000 is our number. But the problem is you can't write 90,000 in 3 sig figs. It's not possible. Because if you put a decimal at the end, you have 5 sig figs. If you don't have a decimal, then you only have 1 sig fig. So the only way to write it as 3 sig figs, if that's what your tool says, is to write it in scientific notation because you're allowed to have 3 sig figs, but you can also say times 10 to the 4th grams. So it tells you that that 9 is in the 10,000ths place. So that is how we write in scientific notation. We will practice this in class.